limits at infinity means that either the x is approaching either positive or negative infinity, or the function itself is approaching positive or negative infinity. In this case, it's the x that's approaching infinity. When that happens and the x is going to either positive or negative infinity, there's a couple of ways to approach this. My favorite is you really only need to compare the leading term for each polynomial. Because if x is going to infinity right here for the numerator, to figure out, hey, what's happening with the numerator? Well, we've got 2 times x, so that's going to be 2 times infinity, which is infinity. And then adding 9 really doesn't matter, because if you already have infinity, in fact, a double infinity, then adding 9 really doesn't do anything. So you can say this is pretty much going to be the same as the limit as x approaches infinity, and then just use the leading term and the leading term. So the same type of thing. Infinity squared, that's much more powerful than adding 8 or even adding 5 times infinity. So use the most powerful term, which is the x squared. And then you can do some algebra, because you can cancel x's. So you've got the limit as x approaches infinity, and then 2 divided by x. And 2 divided by infinity is 0. You could think about it as, well, this is $2. Take $2 and divide it amongst an infinite number of friends. How much money does each friend get? Yeah, pretty much nothing. So this is going to be 0. I am going to show you another method, but I want to use the calculator to check that I've got this right before I go into that other method. So we've got, here's the graph. In the middle it does some little wavy stuff, but over here as x gets bigger and bigger, the function is extremely small. So if we trace it and follow it out to the right, which is what x goes to infinity means, follow it out to the right, you'll see that the y value is just getting smaller and smaller and smaller, and we're not even that close to infinity yet for the x's. And so it's gonna just shrink down and down and down until it's practically nothing. So 0 seems to be the answer. Okay, here's another way, and some people like to do this. What you do is, whatever the highest term is, or the polynomial with the biggest degree out of all of the terms, take that and divide all of the terms by that. So you'd have the limit as x approaches infinity, and so we'd have x squared gets divided by x squared, the 5x gets divided by x squared, and 8 gets divided by x squared, and 2x divided by x squared, and 9 divided by x squared. So for me, the disadvantage of doing this is you have to write all of this extra stuff. But you don't have to write the squiggly equals, because it's not an approximation, this is exact. So now reduce. We've got limit as x is going to infinity, and it's going to be 2 over x and 9 over x squared, a 1, a 5 over x, and an 8 over x squared. And now we're going to use the same logic as up here, that if you have a constant number divided into an infinite number of pieces, the size of each piece is pretty much nothing. So that means this one becomes 0, and 0, and 0, and 0, and a 1. So we get the answer is 0 plus 0 over 1 plus 0 plus 0, which is a 0 over 1. And that is the same thing.